So. Hallo, hallo, hallo. Hi. Hi, Biop. Wait a second. Good luck, impossible, easy puzzle. Yeah, I definitely need luck. Actually, something I should really do is look at my last stream to see what I actually did to get the brown platform. Because I forgot how I got the yellow Koopa, and I forgot what I did to the yellow Koopa. I think I ate it when like big or something? I don't know anymore. That's a bit of an issue. Also, hi Magikey, enjoy nothing, and yes, it's only 2 screens. Wait a second, I need to write something down because right before I started stream I built something very stupid. Potentially the most stupid thing I've ever built. I'm not even sure if I'll actually put it in a hack, because it is so stupid. But okay, anyway. Okay, so this is the save state that I had. I have right in front of me a yellow Koopa. And I kind of forgot what I needed to do with it. Also, I swear this is yellow Koopa, by the way. Right, okay, small Mario. Small Mario gives you Fire Flower plus brown platform. Okay. And then starting from this, you could try to like get a 1-up or something. I cannot speak anymore. From this you can try to get a null sprite and then power up implementation on the brown platform. Or find another pixel on the brown platform, right? Because what happens on the brown platform depends a lot on stuff. How do you get on? You ask the correct questions. Should be fine though somehow, right? Some way you should be able to get on this. Maybe you don't actually get on this. Maybe this is all a ruse. I didn't properly think this through, you know? I kind of never looked at the ceiling properly. Because why would you? Why would you look at the level when you're playing it? But I mean, you can make it through here, stand on the brown platform here. I mean, assume for a second I was up here. Maybe up here. Oh, this works. for some definition of works. Hmm. I mean, you can get up here, right? That's not the issue. I think the issue is more getting down again. Hmm. Wait, what is up here? Did I just... I'm confused. Wait, what am I ramming here? I'm ramming a ceiling. Why do I touch a ceiling? Where does the ceiling come from? Why is there a ceiling here? There should be no ceiling here. There is no ceiling here. What? Oh no. I'm hitting ceilings. I'm hitting ceilings where there shouldn't be ceilings. I mean, you can get up here, right? That's not the problem. That's somehow the least of the problems. I think. Huh. Huh. What am I hitting here? Please don't tell me this becomes relevant. But I mean, this is like... This is custom behavior, right? Like, there shouldn't be a ceiling here. Could be the slot 2 springboard writing to 69.3. Shouldn't be though, because that should always write there, right? This is the sprite in the lowest sprite slot. So if it's writing, it will always write. Also, the Reznor has... none of the tiles here have the correct Map16 ID. You look on Lunar Magic. Well, you can't see the tooltips. This is 276, this is 275, this is 266. 265. This is 38E, 37E, 36E. This is 43A, 439, 43B. There's nothing in this area here which has the relevant ending, right? Which is 21, 22, 23, 24. So somehow this is not it. Somehow this is not it. I have no idea what's causing the ceiling. This is a do not use level header. Yeah. Horizontal level mode. Yeah, I mean, I get what you did here, but it just randomly creates ceilings off screen. What's going on? Okay, so you can touch the brown platform like that, but then it's hard to get down again. I think this is the true lesson from this. Huh. What kind of save states do I have? Oh no. I feel like I don't have good save states. So now we hope this position is the one we want. Yeah, but then I still don't know how to get down again. barring like extremely elaborate setups that I don't want to get into, honestly. This is a bit not so great what's going on here. I mean, I guess. By the way, I find it a bit weird that ducking actually works. Like, I have to duck to even activate this. Okay, maybe the brown platform is actually in a very bad spot this way. Actually, wait, there is a way to fix this though. It's somewhat weird, but you see, let's rewind to before I dropped the brown platform. You see, if you... Okay, I'm just not going to demonstrate it because somehow I think most people here know the glitch. Okay, maybe I should actually double check that this works the way I think it works though. Maybe I should double check. Let's spawn a bunch of sprites. Hello? Oh no. Yeah, I just mean item swapping it. But I'm curious what happened to my sprite in slot 0. Oh wait, am I poking the wrong address? I might be poking the wrong address. Oh, that's bad. Am I stupid? I might be stupid again. Yes. What was I poking? Some garbage. Okay. Hello, Springboard. I don't know why you exist, but... what else can I spawn in? A Koopa. Very nice. What else can I spawn in? I just want to double check that everything works. And I do this by spawning in a bunch of sprites. So, hello? I don't know what I just created. Wait, what did I just create? Okay, I'm not testing it this way. I just know that it works. Right? I just know that how it works. If you have a sprite on Yoshi's tongue Basically, if all sprite slots are full and you drop your item box, then the thing in the item box replaces one of the sprites that exists in the level. Right? 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 Is that how it works? In any case, sprites of 10 and 11 are full, you can just item swap it using something else. Does that work? If every sprite slot is full, the reserve power up replaces something in the level, right? It's not that it just doesn't spawn. It does replace something, right? And that should be achievable in this. In any case, you can also item swap it in any other way. Somehow should be able to. You should be able to get the brown platform down. That somehow shouldn't be the problem. But yeah. I just have the flying block or a falling mushroom available. Yeah, I mean either would work, right? I mean I currently have a falling mushroom available, so I could just item swap using that. It's even in Sprites of 11, so it would naturally work. Only problem is that I got rid of all of the things that can damage me in the process of getting this brown platform, but surely that's fixable. Okay, but with all of that said and done, this still does not clarify at all what I actually want to do in this hack, right? Because now I've done a bunch of stuff, but the bunch of stuff doesn't actually help. Like somehow the bunch of stuff I can do just doesn't help. So the thing is, there's this room, right? This room where you spawn, you get a midway point, you get a mushroom in your item box, and then you need to activate a keyhole. And so somehow the first question that you should be asking, I guess, is there any way that this mushroom gives me a key in my item box? And this is something you can just check. This is a finite check. So let's just do this finite check. So this is, as always, the disassembly. So let's... good thing the word power up is used only 99 times. Oh no. Where's the address again? Where's the routine for giving you a power up again? Oh, that's pretty good. Okay. Item box sprite. This seems pretty good to me. This seems like the correct routine to me. Also, I should probably close my window because the road is getting quite loud. Not sure if you can hear that, but whatever. Window closed. So, with that said, what does 0 mean? 0 means nothing. What does 1 mean? 1 means mushroom. What's a mushroom sprite ID? 74. What's a key sprite ID? 80. What's 80 minus 74? C. So I need D to be the entry in this table. Also, oh no. Okay, so how does this address actually work? How does this routine actually work? So, usage, sprite ID in A. So the thing I would need to know is, are we 8-bit or 16-bit today? Looks a lot like 8-bit to me. So in particular, ASL, or ORA19 will cut off at some point. Okay, so what do? We do SEC, SBC74, but this is subtract to width. Carry, does this matter? No, this should just be the thing you expect it to be, right? Because SEC, SBC. There aren't many routines that start in 16-bit. That is absolutely true. You just need to check that this is indeed one of these most routines that start in 16-bit. I'm aware though, right? I mean, somehow I have read S&W code. Most of it is 8-bit, but better to double check before you assume things and do the wrong thing, right? Okay. So we have 40 chances to hit a D. And by 40 I mean 64. I don't know why I said it in hex. One, 1, 0, 1, 0, 1, 4, 2, 3, 5. Okay, what's the next one? Maybe I should just open this in the hex editor. Might be faster to just open this in the hex editor. Wait, where's my... Okay, here's my unheaded... C510. How do you convert this to PC addressing? It's just C510. Okay. Let's just... Here, let's look at the code in this way, because this is surely the correct way to look at the code. So it's this one. This is XVI32. I have no idea if this is any good at anything. I just have it lying around since like over a decade. I don't know, I downloaded it like ages ago. Okay, so are there any Ds? Do I see any Ds? There's a conspicuous, like, oh, that's a D. C547 though. That's misaligned. Okay, don't care. D. C586. Wrong alignment. D5-8C. Wrong alignment. C5-9T. Also wrong alignment. Oh, this is unfortunate. C5-9D. Ah, correct alignment. Okay. That's good to know. Why do you need alignment? Because you collect a mushroom. And given how look at how this table is organized. Am I stupid? Oh wait, I don't need... Good morning. You don't need alignment. You don't care about alignment. Oh, I misread the code. Thank you for pointing this out. Thank you for pointing this out. I misread the code. Yeah, we start here. Yeah, you're correct. You are correct and I'm wrong. You are correct and I am wrong. So we collect a mushroom, SEC, SBC 74, ASL, ASL. We get 0, we OR a 19. Which means this is 0, we OR a 19, so this is basically just saying LDA 19. TAY, LDA item box sprite Y. Okay, so we just check for every D. Nah. Okay, so here's our first D. Okay. Okay. Nope, I wasn't doing anything. I just went back to the first 0D and then I wrote something on a piece of paper to like make sure that I don't forget this until next week. Okay. Okay, so we start at C511 if I got this correctly. No, C510. Ha, already wrong. C510. Okay, so we start at C510. So I just need to so I just take the address and subtract 10. Take the address, subtract 10. Okay, so this is C547, so with power up 37. What is this? Power up 76. What is this? Power up 70C. What are you? Power up 80. Power up 8D. We're reaching the point where power up decrementation would be faster than power up incrementation. Okay. Okay, so there are exactly 5 power-up states that give you a key in the item box when you get a mushroom. I mean, this is a slightly wrong statement, because a priori, I mean, because collecting a power-up does more than just putting something in your item box, right? Because collecting a power-up also does the following thing. it indexes this table. Which is just this, yeah, it indexes this table. And then goes to handle power-up pointers. And then jumps there, right? So let's check which routines are being called for these various ways of getting a key in the item box. So with power-up 37, so how do you get this? You just add 14, hex 14. So currently we're at 47, 47 plus 14. Which routines? My favorite routine is located at 014A13, you know? That's my favorite routine. Yeah, 014A13, our favorite routine. Anyway, okay, so we are at, so this 0D, so we are at 47. So now we go to 50B, 5B, 8, 9AB, yeah, 5B, so we go to 5B, C5. Okay, so we execute the C5th entry of the table below. Let's not look up where that jumps for now. Let's just note that. So 76, this is 76. No, this is 76. So we go to 9A. Nah. Where's 9A? 85. Okay, routine number 85. Surely that's a well-defined routine. Nothing will go wrong there. 8C. 8C plus 14 is A0. Where's A0? A0 is here. 1D. Okay. 1D. So the next one is this one. E5. Surely there will be nothing wrong with E5. Wait, you cannot actually. I was about to say just move this. Shrink this, but you can't. You can probably change the alignment somehow. I have no idea how to use this. Now it's adjusted to 48 bytes, but now it's no longer full screen. So you can actually adjust this. Reasonable things are happening, but I don't actually care about this, so let's not care about this. So what's the last one? 8D. 8D would be plus 14 A1. What? Wait a second. I'm off. Way off. I'm doing stupid stuff. I'm doing stupid stuff. I can't add numbers. No, I can add numbers. I'm good at adding numbers. Forget what I said. I'm good at adding numbers. I'm very good at adding numbers. Ignore what I just said. I can actually still add numbers. I thought I had like a calculation mistake, which would have been pretty annoying. I can still add numbers. It's fine. What is this? 7F. Okay. So the next step is to look at this pointer table and look out for the correct pointer. This is a pointer table which is 2-byte pointers. Okay, so this is a 2-byte pointer table. Each pointer is 2 bytes. So what I have to do is I have to index this pointer table using the indices I just found. Which seems like a perfectly good thing to do. You like that lone RTS without a label immediately after a pointer table. I mean, why should you label it? Return : RTS. But actually, why do you even have the RTS there? That's the actual... Yeah, I mean, actually, why is there an RTS there? Why would we need to go there? Why is this there? Who put that there? Who put that there? Well, okay, somebody put that there. 1 byte wasted. It's a good RTS. Okay, so let's index some tables then. Ahem. So, let's index some tables. Okay. Pointer table starts at 554. So I just take the numbers that I just got, multiply them by 2, and add 554. Seems like a perfectly reasonable thing to do. Maybe I should use a calculator for that. Anyway, I'm too stubborn. Why would you use a calculator if you can also do it by hand and then miscalculate and then cry? Yeah. You see? All the advantages of doing things with pen and paper. You can get very mad at yourself in the end. Why would you use a calculator if you can write a script to print all to the screen? Asking the important questions. Okay, let's go into the hex editor again. Let's go to address C58E. I feel like the tables that I'm indexing here are quite overlapping. Okay, C58E. DA6E. Okay. That's at least still in ROM. Okay, what's the next one? 652. E8, A9. I'm doing the endianness correctly, right? Oh god. Please do it. Please, please, please. Do I do the endianness correctly? C556 should read 6fc5. 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 Okay, okay, okay. I do the pointers correctly. Pointer endianness correctly. Endianness is correct. 6fc5. That reads. Yeah. Okay. Perfect. Go to 6-5-E. C65E. 8A03. 8A03. You know what I like about all of these addresses? They're not open bus. So they all have a pretty good chance of not immediately crashing the game. Okay, what's the next one? CDE. 15E9. Okay, that's also not open bus. Although it is a bit more volatile. You probably shouldn't execute 15E9. But okay. Okay, you can execute 15E9. The world is not going to end if you execute 15E9. Oh, probably the game is going to end if you if you execute 15E9. E679. Also good. E679. Okay. So let's look at what all of these routines are. Starting with my favorite routine, the one starting at 15E9. Sprite index for the current sprite that is being processed. Sprite index to the OAM table. Wait. You know what the first thing is? And the next thing is so volatile that this is probably already an ace entry. Or just BRKs. Well. It'd probably just be RKs. Okay, anyway, let's ignore that for a second. Let's look at the ones... Let's look at the ones that actually start in ROM. So, starting with 018A03. Wait a second, I should probably check how we actually get here and how we get out of here normally. Because depending on that, something like an RTL or an RTS might crash the game. How are we expected to get out of here? How do we get to touched power up? Okay, so we branch to this. So we want to RTS. At the end of all of this, we want to RTS at some point. Maybe this RTS should have clued me in. What does this do to the stack again? It's a JSL. But I think it's end up being stack neutral. I think it's basically a... Yeah, I think it's basically a JMP... JML? JMP. I think it acts like a JMP, this JSL execute pointer routine. Yeah, like I think JSL into here acts like a JMP in some sense. So I think this ends up being stack neutral, and I think we still want to RTS after doing this. I guess I can just check this routine. Wait a second. This routine is what I should check. By the way, what the fuck is this? What the fuck is this? No! It JMP's here. This is a very good JMP. Okay, so we JMP here. Okay, so at the end of all of this, we RTS. Okay, so we want to just go to the first RTS and then be happy. So let's see if any of the routines that we found, like 018A03, RTS. Okay, so unfortunately 018A03 starts with a 9E. So it already starts misaligned. What's 9E? Wait. No, sorry, we jump here. FF. You should probably actually read the code and read the correct line. That would help. We start on this FF, which is an SBC. So we SBC the LDY, okay, I don't care what it means. Then we do 9E. So we STZ something, we STZ the CPY. Wait, no, this is STZ... No, wait. Wait, what's that? ALX. What's the ALX adjusting mode? Oh, wait. It is SBC ALX. Okay, so we SBC and then we treat these three as the operand. This is a 4-byte instruction. Oh no. Okay, so this FF is the first thing that gets executed, and it is an SBC 4-byte instruction. Let me just make sure I get this correctly. Yeah, this is a 4-byte instruction. Okay, so since this is a 4-byte instruction, I don't really care about this. This is definitely the optimal way of doing this. Yes. Okay, so we do this, treat this as the operand, and then we do a COP. And I think the moment you do COP, I think you lose, right? I'm not checking where the COP goes. Also, COP pushes to the stack. No, COP pushes to the stack. I'm not going to check what this does anymore. This COPs runs into a COP immediately. I don't care. I don't know what this does. Go away. Go away. Let's check a different routine. Ah, okay, also misaligned. Okay. What are you? Part of the rope mechanism. But I mean, how would you do this? I mean, what is the correct way of doing this, in your opinion? Using a hex editor that can disassemble. Recommend a hex editor. Please. Please recommend a hex editor then. S-hex. Where am I supposed to get this from? Let's see. Okay, so we have a 2015 C3 post as a download link. Yeah, I already found the 2000. Okay, this is the same link that the 2015 C3 post gave me. So, pretty good. Let's see. No, I do not want to compile stuff, and especially not on stream. I'm not starting to compile stuff on stream. What could possibly go wrong? Yes, what could possibly go wrong when I start compiling stuff on stream? Okay, so here we go. Where were we? Wait. Wait. Go away, go away, go away. I should probably open the unheadered one. Because otherwise every index... No, wait, it already removed the header. Okay, great. It already removed the header for me. Very friendly. Okay. Good thing that it does that. How do I use this? Select, then Control D. I'm confused. I am confused. So let's say I want to see what DA6E does. What am I supposed to disassemble? Why is it... What? Wait a second, if I select this, it just doesn't do anything. But if I select only like this, what? If I select this? No. Hello? I don't get this. Could you... Okay, Control D just doesn't do anything. Control D just doesn't do anything. It just doesn't work. Huh. Interesting. Okay, let's just double check that the 8A03 that I ran into... that actually COPs. Should COP though. SBC, COP. Yeah, no. We're not executing that. This is a hex editor. This is shex. It is a hex editor that was recommended to me by Via because it can disassemble, or no, assemble. Disassemble? Assemble? It's called disassembling. No, actually it's not, yeah, it's disassembling. That can disassemble. Can disassemble. Okay, what do we do here? BCCDA. What made you want to use this? That's an interesting question. Which almost makes it seem like what I'm doing might not be the intended way of approaching anything, but okay. What makes me want to use this? So basically, I'm in the situation that I want to beat this level. And this thing that happens right as I enter the level is that I collect a mushroom. Collecting a mushroom does two things. It puts something into your item box and it jumps to an address. I mean, I guess I could just collect the mushrooms and just see if stuff crashes, but I want to actually see what happens. For example, collecting a mushroom with power-up status 76 would put a Magikey in your item box. Except for the fact that it runs into a COP immediately and crashes the game. Truly unfortunate. I guess I'm just going and crashing my game for now. Wait. Do I not have an overworld? I did not make an overworld save state. Oh, okay. Probably faster, I just have... We're also looking at vanilla SNW and assuming it's the same as the edited ROM. It would be truly fucked up if that part of the game was being edited, though. Like, this part of the game I think is never edited in like any of the tools. Like the one thing we jumped into was some Koopa related code. One thing the game jumps into is some rope related code. The sprite rope, right? And the power-up stuff is just like the power-up routines code, which I think is, yeah, it's also not being touched. Okay, so... Wait, I should have maybe dismounted the Yoshi. Okay, let's poke some things. 37. Wait, are these several mushrooms? Sometimes you should maybe check the basic things first. No, it's one mushroom. Wait, it's one mushroom. It is one mushroom. We've not remembered much last stream. Oh. Yes. Correct. Correct. Right. It is so unintuitive, though. I remembered all of the intuitive stuff, I swear. Why is the game like this? I think this is one of these cases where you actually want to edit 0db8. Which is the Mario's power-up status. Okay, I feel like this crashed the game. I don't know why I think that. To be fair, we're jumping to 15E9. I think I'm going to skip 76 because it is just going to crash the game because it runs into a COP. Slightly unfortunate. Where did I go? Oh. I like this Y position. You see the Y position? Pretty good Y position. I mean Mario's Y position, you know? It's a pretty good one. To be fair, if it was a little bit higher, like if it was a little bit higher, it would overflow and the camera would snap you down. That would be pretty epic as well. You know, if your Y position is like minus 32,000, then you do actually survive, and you just the camera just snaps you down because you're above the level, not below, right? Which means that if you somehow manage to not die with Mario below the screen border, then he loops in half the amount of time that you would think he does. Maybe I should check what actually happens here. This looks promising, because it at least doesn't crash the game immediately. Power up 80. Boing! 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 This is way too funny. Just start the level and just boing? Okay, I guess that's not really what I want to. It changed the output of the RNG routine a few times though. Pretty cool. Okay, so this seems to crash immediately. Let's just double check the 76, but I think 76 is just going to crash my emulator. I mean, I guess it is just a COP, what should possibly happen? After all, only STP crashes the emulator. Hi, Milgrips. How is puzzling? So... Here are the following things that happened during this puzzle already. I used the text editor and disassembled a bunch of stuff. I read the disassembly and... wait a second, you haven't seen this. This is great. Boing! And you die. That's beautiful. Just beautiful. What I'm currently doing is I'm trying to enter a level in such a way that I get a winged key into my item box the moment I enter the level. That requires... Well, maybe that requires a bit of explanation. So somehow what I do want to do is I start in the level, Mario touches a midway point. You collect one mushroom. It being a mushroom, it is a power-up, so you get something in your item box, and if you have glitched enough power-up status, then this can put a key into your item box, which is very useful because that allows you to activate this keyhole. Don't use this key, it doesn't work. Unfortunately, all of the power-ups I can use for this, there are exactly 5 power-ups which would give you a key into your item box. Out of them, three seem to just crash the game, one seems to put me way below the death barrier, and one does the boing. I'm not really sure what to do now. Boing. You got home now at 9 PM after you left for work at 6:30. That's long. And that's very early. That just sounds unpleasant. It has been a work day. I see. I see. Hi, Durf82. Very early that tell that your cat that wakes you up at 5 a. Okay, I will just admit that I haven't woken up at like 6:30 or earlier in probably like half a year. Maybe that's a lie. Maybe like once in the past half year. So, for me, that's like way too early. I don't know how to wake up at 6:30. I lost that ability at some point, I think. Maybe I will regain it. You stay up past 6:30 more than you've woken up before 6:30. I'm pretty sure I have done like neither. The past year at least. And staying up past 6:30 also I haven't done like much. Then I think like my... I don't know. No, I mean like... I think in the past half year I've done neither. Certainly not being up past 6:30, so... Okay, back to disassembling. So... Okay, so let's check what happens during the boing. E679. Okay, so we STA somewhere, probably not so important. We ADC somewhere, probably not so terribly important. Right? We TDC, but 64. The RAM map says properties byte for most sprites inside levels, including the player. Exceptions to this include... What does this even mean? How can something in RAM be the properties byte for most sprites inside levels? What does this even mean? What is the RAM map say? What? It means most sprites or A64, most don't. Okay. But... But then what is it? Like, when does it get set? Is it just a constant? If it's a constant, why is it in RAM? If it's not a constant, where does it get set? Why does it get set? Who decides what it gets set to? Given that it's a YXPPCCCT byte, does it change when I turn around? Because that certainly changes the X part of the YXPPCCCT of the player. What is going on? What is this address? I mean, let's just double check. Okay, it's 32. It's 32. It's just the constant 32. Okay. Now, unfortunately, STA square bracket 64 means read. Wait, what does square bracket 64, comma y mean? It means read 3 bytes at 64, right? Treat that as an address and store there. Ah, it's probably storing to ROM anyway, who cares? ADC 64, I don't know, I don't care. What is this? TDC. Ah, just changes the, wait, transfer D to C. That's what TDC does, right? So this just changes the transfer direct register to C accumulator. Yeah, okay, who cares? Just changes the accumulator. Then we LDA02. And then we STA1471, and this looks a lot like aligned code. This looks like very reasonable aligned code. Where are we here? So this just STA some random address, who cares? ADC, TDC, LDA02, STA1471. Where are we? Where are we? Where are we? E679, 01 E679. I mean, it feels like a node block routine to me. No, it's the springboard routine. Okay. Boing. Boing. It's part of the springboard routine. More specifically, it is Mario is standing on a springboard. That's the LDA02 STA1471. It is Mario is standing on a springboard, according to the disassembly here. This is the springboard main, and this is where we jump to. I mean, strictly speaking, we jump to this 97, I think. Which that's again this 97, and then the STC72, and then these SD sets are the reason why there are 64s there. And then the 7B is the TDC, and then this LDA02 is, yeah, the correct thing. Well, this is how we got here. Okay, so this is Moing. And so you always get springboarded. Which leaves DA6E as a reasonable option. Let's check what DA6E is. Let's disassemble that for a second. So here's a bit of a problem. It starts with BCC, and I have no idea what the carry is. Now that's truly unfortunate. I mean, I could ask the emulator nicely, but then it still won't tell me, I think. I mean, I could run a trace log, but let's just figure out this way what the carry could be. I mean, it is part of the get power up routine. Wait, what? No, please. Yeah, there we go. SEC, SBC. Oops, I should not change my disassembly. SEC, SBC, ASL, ASL, ORI, TAY, LDA, BEQ, STA, LDA, STY, LDA, JSL. So let's execute pointers, change the carry. I should maybe put the colon there. STY, PLI, STY, REP, AND, ASL. ASL. ASL sets the carry. T-A-Y-P-L-I-S-T-A-N-Y-L-D-A-S-T-A-S-E-P-L-E-Y-M-J-M-P. Okay, so ASL is the last thing that could set the carry. And since we AND'd 0F00FF, and then we ASL'd, arithmetic shift left, so the carry is not set. So the branch is taken. Branch of carry clear. Okay. BCCDA, that's a backwards branch. How far do we branch backwards? We branch... Wait, how far do we branch backwards? How far does a BCCDA branch backwards? Ah. Oh no. Oh no, oh no, oh no. Okay, what's DA? DA is minus 38. So we just branched 38 bytes backwards. But it is 38 bytes relative to this guy. Or more precisely, we branch to here. This is what we branch to. Disassemble this. Ah, this is aligned code. Okay, so code aligns. And we... Did I do this correctly? Yeah, I think I did this correctly. So this is fine, and so we STA96. Oh, we STA96. I have the feeling I know what 96 is. Player Y position within the level. Oh no. What's in the accumulator right now? What's in the accumulator right now? JMP00, SCP SDA00, LDA00Y. Wait, why am I so confused about what's happening here? We LDA. We STA. We SEP, we LDY, we JMP. So what's an A? This. Which is the same thing that was in 00. And there we JMP. So what's an A? The pointer is an A. The current pointer that we just jumped to. What? Do I really have to get out of the disassembler now? Because, like, what I'm just reading doesn't make sense. What I'm reading doesn't make sense. So the thing is, maybe I should read on. What is that code actually? It's rope code, but which part of the rope code is it? Move Mario's Y position with a rope. Also, if he's too high up on the rope, move him downwards. Okay, so we're just in the middle of rope code. That seems honestly pretty reasonable to be in the middle of rope code. Probably doesn't crash the game, and I mean it does not crash the game. It just kills me. But why does it kill me? I don't understand. What should be in the accumulator, if I understood correctly, should be DA6E. That should be in the accumulator right now, because this is what we jumped to. It should be DA6E. And we jump here. And we BCC. And then we jump here. Wait, we jump here. No, we jump here. No, here. DA4A. I should actually read the addresses that I'm clicking on. So we execute here, here, and we jump here. And so we SDA96. Oh, TYA ADC 97, SDA 97. You should sometimes read actually what the code says. Oh. Sometimes you should read what the code says. I was like, wait, but 96, 97 is not what I think it is. Yes, of course, because there's an SDA 97 coming right afterwards. Like, just read the code. It's not so hard. Okay, yeah, SDA 96, TYA. What's in Y? What's in Y? I think in Y is what was in Y before I collected the power-up. What should be in Y when I collect the power-up? Wait, what should be in Y when I collect the power-up? Okay, what should be in Y when I collect the power-up? Well, it is SEC, SBC, ASL, ASL, or A19TAY. Okay, this is Y, then JSL execute pointer as Y preserving. This is Y preserving, this routine. You can look at it as Y preserving, it's fine. It starts STY03 and it ends LDY03JMP. It doesn't modify 03 in between. Okay, so this is SEC, SBC 74, ASL, ASL, or A19TAY. So what is this? SEC, SBC 00, or A. So this is just 19. So what's in Y? Mario's current power-up status. What's Mario's current power-up status? 7C. So what happens here? TYA. Wait a second. I'm extremely confused right now. How does execute pointer work? REP30, SEP30, LDY03. Okay, SEP30. So where execute pointer leaves in 8-bit mode, which is what you would expect. Okay, great. So we leave in 8-bit mode. REP30 enters 16-bit mode, SEP30 enters 8-bit mode. Okay, that's good. That's what you would expect. So what's in 03? What's in Y? Y is just 19. And we're in 8-bit mode. So how does it go? SDA 96, I don't care, TAY, ADC 97. SDA 97. What's 97? 97 is the high byte of Mario's Y position. So we add Mario's current power-up status to the Y position. That's what TYA ADC 97 SDA 97 does. So we add, in fact, because the carry is clear. So TYA ADC 97 SDA 97 just takes Mario's current Y position and adds the power-up status. And the power-up status is 7C, because that's how we got here. And 7C is very large, but it is positive. And so we always end under the level. Okay. And so this is the reason why doing all of this at the end of the day this is why through all of this, after all of this, you end up way below the level and just die. Truly unfortunate. Okay, this seems to mean that this is a bad address. And similarly, that this is a bad power-up, because it just kills you. And similarly, this seems to be pretty bad, because you just boing and die. And I don't like it when you boing and die. So that's also pretty bad. So I guess this leaves... Well, what does it leave? E8, E9? But that crashed the game last time. Okay, let's see what E8, A9 actually does. Shall we? Yeah, I mean, it crashes the game. Obviously it does, right? It just finds aligned code, but PLYs, and the game crashes. Okay, great. Yeah, no wonder this crashes. Like, why does this crash? Because it runs into aligned code, but PLY is one too many times. So the stack is corrupt. Goodbye. Game over. You won't return from this. But that's weird, because that means the summary of this entire odyssey right now, of these past 1.5 hours, is there exist exactly 5 power-up status of Mario, for which collecting a mushroom puts a winged key in the item box. That's observation 1. Observation 2. For all of these power-up statuses, the routine that gets called as like the visual transformation routine is not one of the intended ones. That's to be expected. The first one starts in RAM. The second one starts somewhere within the code of a Koopa and pretty much immediately COPs. In case you don't know what a COP is, it's a opcode that typically crashes the game. And by typically crashes the game, I mean like it always crashes the game because like somehow COP is one of the software interrupts. So I don't actually even know where the COP goes. So internal SNES had a native COP vector. 82C3. Wait, what's 82C3? Wait, what is 82C3? What is 82C3? RTI. Wait a second, the COP vector is actually put. Wait, so I actually need to read what happens at AA03. COP doesn't just immediately crash the game. Wait a second, what? Wait, what? Ah, I guess I was just wrong. So they did actually set the COP vector, but they did not set the BRK vector. So BRK always crashes the game, but COP doesn't crash the game. Instead, COP is just a nothing command. Ah! Can't you like trust that anything is consistent in this? No, it's S&W. Nothing is consistent with this. That's why I play it. But, Okay, good thing that I checked that again. What the COP vector is, it's 82A3, it's a nothing command. So let's go back to 8A03. And let's check what happens at 8A03, because I was like, this runs into a COP, this will crash the game. And the answer is, no, that's not how COP works. So disassemble. Instead, SBC, some garbage address. What is this even? It's in ROM. Okay, whatever, just changes the accumulator, nobody cares. COP does nothing. COP does nothing. Actually, what does a COP do? Wait. Wait, what does a COP do? Maybe the COP still does crash the game. Because I think you're not allowed to just point COP to an RTI, right? What does COP do? No, you are allowed, right? Or you are allowed to point a COP to an RTI. Okay. Fair enough. This is just changes the accumulator to something I don't care. COP, LDY 9D. Just a constant. ROL 16, X. So what's an X? Important question. What's an X? Probably the sprite slot of the mushroom we collected. Which is 6. So ROL 16X. Probably not so. That's probably a bit dangerous. Ah, no, it's just a hardware mirror. Wait, it's a hardware mirror. Oh. I don't like the fact that we ROL 1C here, but it's just the layer 1Y position. What could possibly happen if you ROL that? Actually, what does happen if you ROL the Y position? Nothing, right? Because the Y position is probably, the layer 1 Y position is probably 0. I guess that's something you can just check. Once again. Oh no, it's 192. Wait a second. That might be bad. Sorry, I'll, no, what? I'm confused. But X should be the X should be the sprite sort of the power up. So wait, what does ROL do? I'm confused. Do I actually have to open? Oh no. Why are things not behaving the way I think they should? Maybe address 1C just doesn't work the way I think it does. Is address 1C a read-only mirror of a SNES register, or is it also being written to during the NMI routine? Sorry, is it copied to the thing it's mirroring? That's the question. Anyway, let's just ignore this for a second. Come back to this question later. So then we JMP to 18913. So we JMP to 8913. That seems like a reasonable address to me. And we... What is crashing the game here? Something is crashing the game, and I don't understand what it should be. Because we SPC, COP, COP, LD. Wait, does the... No! What? Is this crashing the game? Did I fuck up the... Which power up are you checking? I'm checking power up 76. I am checking power up 76, which should execute power up routine number 85, which should index the pointer table with an offset of 10A, which hence should read the pointer at C65E, which hence should jump to 8A03. This is my analysis of the situation. Maybe I should double check the analysis for a second. Because something is behaving in a way that like sort of shouldn't crash as badly as it does. It just immediately crashes, while also not doing what I think it should do. So this is the power-up table again. So we should start at C524 and add 76. 24 plus 76 is 24 plus 76 is 9A. So let's go to C59A. And we find an 85. That's the 85 I want. Can you read this on stream, by the way? It's pretty small. But okay, but anyway, that's an 85. And so the 85, if I multiply by 2, it is 10A. That's a just correct calculation. I add 554 because that's where the pointer table starts. 10A plus 554 is 65E. Also correct, there's no mistake in this calculation. And so if I go to 65E, C65E, I jump to, so I read 038A, which means that the pointer jumps to 8A03. I have no idea. Can I make this bigger? Can you make this bigger? I guess I can like make the window smaller and then zoom in on stream. Except that I can't resize this window in any way. But you can change your font size. Haha. Good thing that this thing is not considered a font. And so font size doesn't apply. So yeah, too bad. Also, yes, I love how it resizes whenever I disassemble it. It's a beautiful, beautiful feature. Okay, so we jump to 8A03 again, 018A03. So 018A03, we start here and then we disassemble. And we start once again with SBC C09EB4, X. We COP, we LDY9D. We ROL 16X, we STZ 1528X, we JMP to 8913. This is where we JMP. And so this is a non-issue. This is a COP that just COPs into an RTI and so does nothing. This is a COP that just COPs into an RTI and hence does nothing. This just changes Y. Who cares? This ROL 16X changes. Well, maybe I should double check what X is. How did we get here again? How did we get here? Zero one C4 AC. By the way, I'm slightly confused when this routine is being called. But maybe it's not so bad. Maybe I just shouldn't care so much. No, we come here directly from the Fire Flower main routine, which is the same as the Mushroom main routine. Right? This is how we got here. And so X is the sprite slot of the current sprite being processed, which is the mushroom. So X is 6. But if X is equal to 6, I guess there is the non-zero chance that I guess I should check the actual ROM that I'm playing in. So this would happen in vanilla. I mean, there's somehow the chance that I am actually yeah, but like let's just trace the things again. Somehow this should be quick. So you go to C510, C524, C524, C59A, C59A. Still an 85. Now you go to 65E. 65E, still 8A03. So let's go to 8A03. Should be still the same. Eight A03. Disassemble, we resize the thing. SBC, COP, COP, LDY, ROL. What? Why is this crashing? Huh. I mean, I guess I go to 098913 and like check what JS. Does it really crash? Well, does it really crash? Maybe it doesn't crash. Maybe you are right and it doesn't crash. The thing that confuses me is that 1C is still equal to 192. Yeah, 76 is my power-up state. The 176 is 19, the other 76 is Mario's power-up state on the overworld, the 0 is something you should probably ignore, the 32 is something I can just straight up ignore, and the 192 is the current value of 1C. Which is 16 plus 6. That's 1C. And the thing is, this address should have been ROL'd. And it didn't even get ROL'd. Right? Because if you ROL a 192, you shouldn't get a 192. You should get 65? No, 129. Anyway, you should get some number. But you shouldn't retain 192. You should get 129, right? Or no, wait, ROL... Wait, ROL rotates... No, wait, ROL rotates the top byte into the carry and the carry into the low byte. So the carry is not set, so we go to 128. So the end result of this ROL should be 128 and carry set. Right? ROL takes an address, shifts every byte to the left, shifts the high byte. Am I? I am so confused about what's happening here. What address is that showing? 1C. The mushroom was in slot 6. So X is 6. The moment this happens. Okay, I'm really confused. I'm just going to run a trace log, I think. Let's... Wait, did I poke the wrong thing? Should have poked 76. Okay, so which frame should I trace log? This frame I should trace log. Oh, let's trace log. Okay. Trace log 3 frames. Should be enough to go through. Really confusing. What is going on? Okay, here's a trace log. I don't really like how this emulator spits out trace logs, but well, this is the emulator that I'm currently using. So there we go. So 818A03, this is where we should go. And we do go there. In fact, we go there 3 times. Why do we go there 3 times? I have no idea. Wait, why do we go there 3 times? What? Hello? Something is horribly wrong if we go there 3 times. Isn't there? I'm really confused. Why do we go there 3 times? What the hell is going on? What is going on? This is weird. What is happening here? Okay, let's ignore this. Let's just analyze the first occurrence of this 81A3. So we go there through basically pretty much the process you would expect. SEC, SBC 74, ASL, ASL, ORA, TAY, LDA C510, BEQ C510. Yeah, this is what you go, and this is the execute pointer routine. Then we JMP to 0000. I have no idea why it indents it like this, but who cares? We go to 81.803. And then we SBC, we COP, we RTI, we COP, we RTI, we LDY, we... What? Wait. Are you telling me this fucking hex editor assembles the opcode, disassembles the opcode 3E incorrectly? 3E is ROL absolute X, not ROL direct page X. Fuck. Are you kidding me? Let's just point this out again. This disassembler reads FFB49EC0 and disassembles SBC blah. Okay, fine. It reads 02D0 and it is disassembled at a COPD0. It disassembles A9A0. No, it disassembles 02A9 and sees it as COPA9. It says A09D and disassembles it at LDY9D. And then it sees 3E169E and decides that 3E should be something else than it actually is, because what it actually is ROL absolute X. So it should be ROL 9E16. And instead it just grabs the 16, goes like, yeah, that's fine, and ignores the 9E. And instead goes on with its merry life disassembling the 9E as an SD set. When what should really happen is that we ROL 9E16, because that's what the 3E command actually is. It's absolute X, so 9E16X, and then we PLP, corrupting the stack in the process. And not only do we corrupt the stack, we also mess up the processor flags. So we might not be in decibel mode, we may not be in emulation mode. No, wait, emulation mode cannot actually be changed this way, right? Because emulation mode is only changed through XCE and not through the actual okay, so, but we might be in decimal mode, but we end up not in decimal mode. But what we do end up doing is we pull from the stack, and we have now masked interrupts. Wait, what's the M flag? The M flag is the size of the accumulator, right? So the accumulator is in 8-bit mode, and the index registers are in 8-bit mode now. Which, well, that's the reasonable thing to be in. The fact that the I flag is set might be somewhat unfortunate. Okay, now we ORA 4CX, we ORA 89 relative to the stack pointer as interpreted as a pointer index with. Okay, wait, what the fuck is this opcode? Why does this exist? Whoever uses this? Who thought that this was an opcode? Actually, no, seriously though, when do you ever use this opcode? Like, what is this? What is this? Who is this opcode for? When do you ever want to ORA round opening bracket direct page comma S round closing bracket comma Y? How is this indexing mode even called? You should be thankful for this opcode, else this game wouldn't exist. Is this opcode ever used in vanilla? There seems to be a distinct lack of ORA opening bracket in this. These are the only comma S's in this. This is maybe comma. Wait, how does this disassembly does its indexing? How does this disassembly do its indexing? It would write comma S, right? So I think there's not a single stack relative indexing thing in this entire game. So in other words, this game would exist without this opcode. LM uses it. Okay, but LM doesn't use whatever this abomination is. I'm pretty sure. Like, who, whatever, use this? Why would you? No, seriously, why would you ever want to use this though? So I mean, you start like pushing. You start pushing pointer tables onto the stack? Is this the situation in which you ever want to use round brackets stack relative indexing? When you start pushing your pointer tables onto the stack? I mean, of course, 89 is like a ridiculously large number. You would never ever use an 89 here, right? But somehow, sometimes. Sure. But not only do you want to push a pointer to some data to the stack, you then also, what you're doing is you push a pointer to some data table into the stack, which you want to index using the Y register. I mean, this is what this opcode is, right? It's not only ORA, and not only do you want to that, you want to actually logical OR with that, right? Like, it's not you want to LDA that or you want to STA there. No, 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 no. You want to ORA with it. Like, this opcode is just an abomination to me. Like, why would you ever see the need to do this? I mean, just remember, this opcode could be something like an ORX or an ORY, right? Doesn't have to be this. It could be something reasonable. Or it could be whatever opcode I was looking for recently. Fuck, which one was that again? There was some opcode that I was like looking for that I was very mad that doesn't exist. It was some relative indexing version of LDA and STA. The old man yells at opcode. I mean, look at this. What the fuck is this? I mean, it doesn't matter at all because you LDA right after anyway. But okay, so so basically you run into this routine, and immediately after COPing and LDYing, ROLing, you PLP. And once you are done PLPing, you have now corrupted the stack. Somehow through some magic, your processor flags are still fine, but you have corrupted the stack. What somehow is the complete mystery about the situation to me, and this is the thing that I truly really don't understand. I mean, okay, so I mean, we completely destroyed the game at this point. We BRK, we BRK, we BRK, we BRK. By the way, what's going on at this point? Actually, what is going on at this point? Oh! That's open bus not being tracelocked properly. Yes, 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 yes. This is an open bus, right? Yeah, imagine tracelocking open bus correctly. Couldn't be BizHawk. By the way, what the fuck is going on in this open bus? We end up at 210C. What's 210C? Is 210C a hardware register? It feels like it should be a hardware register. Huh, but none of these are readable either. Why does the open bus ride end at this point? It kind of shouldn't. This is... I am not sure that this is correct behavior at this point. I mean, I have no idea what's truly happening at this point. But this feels wrong. No. You see. Starting from this point, we are doing something which is always the same. You see, nothing changes. Nothing changes. A changed at the very beginning. So A changes right here. And starting from here, you do always the same thing. I have no idea what that could be. But I guess the last thing on data line might have been 8e, so let's just check what 8e is. So on open bus would be an STX. So I guess what I'm going to claim is that all of these are STX8Es. No, that's wrong. What I'm saying is wrong. This cannot be an STX because it's a 2-byte opcode. Huh. Interesting. What would this be? What would this be? Something is going on. Okay, so I have no idea what's going on. STX would also put 06 on the data line. True. But I mean, whatever this opcode is, I mean, we can try to trace the open bus ourselves, right? So we RTS. If we RTS the last thing on the data line, this is horrible. How do you... This is a terrible idea. How do you do this? How does this actually work? So assume you RTS, and after the RTS, you end up at 8120C4. Then what does RTS actually do? Okay, wait. This is actually a fun thought experiment though now. Like this becomes learning something, I guess. Even though it's not learning nothing about the hack anymore. I think. So we RTS. So RTS returns from a subroutine. It pulls the low byte, then the high byte of the program counter from the stack, then increments the program counter. Okay? So we RTS, we pull the program counter, first the low byte, then the high byte, and then increment the program counter. So if I understand this correctly, the last thing on data line should be 20. Okay? Then 20 is JSR, and so we would JSR 2020. So there we go, we JSR to 2020. Now JSR does the following things. What does JSR do? JSR pushes the 16-bit address of the JSR instruction plus 2 onto the stack, and then jumps. So where are we currently? We currently are at 20C4. And so if we push this, we would push... Wait, we pulled first low byte, then high byte, so we push... Wait, how? Wait, we pulled first low byte, then high byte, so we pushed... Wait, sorry. We pulled first the low byte, and then we pulled the high byte. Which means that the high byte was on top of the stack, which means we pushed first the low byte. No, which means the low byte was on top of the stack, so we pushed first the high byte, then the low byte. Okay, this is how we ought to do it. So we pushed the low byte. And so since we pushed the low byte plus 2, we ended up pushing C6. And so my guess would be that C6 ends up being on... that C6 ends up being the last thing on data line. So now we DEC C6. I'm going to go on a whim and say C6 is 0, 0, because C6 is entry 4 into C2, and there's no sprite in C2, so C6 is 0. So DEC C6 underflows. But that's wrong. Huh. That's wrong. This is not what's happening here. Right? This JSR 2020, so this is why we end up at 2020, but what's the last thing on the data line? Because somehow my naive guess actually would have been that the last thing on data line would be the 20, because after we push the C6, we still need to pull the 20, right? But somehow this is not what's happening. After we push the C6 to the stack, we still need to read the 20, right? What does JSR actually do? I would have expected JSR takes the program counter, adds 2, pushes that to the stack. How does the processor work? Maybe I'm wrong about what's in C6. Maybe I should double check what's in C6. Oh, it's 0. Okay, so C6 is 0. Huh. But this clearly says JSR pushes the 16-bit address of the JSR instruction plus 2 onto the stack. I don't understand what's going on. How? Okay, so how does JSR actually work internally to the processor? Ah, this is messing me up now. But I want to understand this now, because this should be traceable, right? So JSR pushes the 16-bit address of the JSR instruction plus 2 onto the stack. But wait, why plus 2 actually? Shouldn't it be plus 3? No, the address pushed is 1 less than the address of the next instruction. Okay, yeah, this is explicitly true. Okay, so JSR pushes the 16-bit address of the JSR instruction plus 2 onto the stack. This is what it says. And so we get 20 C6 pushed onto the stack. And if we want to push 20 C6 onto the stack, the first thing that ends up being pushed is the 20 and then the C6. And then we jump to the 2020. This is all happening in this line. And this is why the stack pointer changes. And the next opcode is C6. And so if it is C6, then it should be DEC C6, because C6 is DEC. And it is direct page, so we DEC C6. But if we DEC C6, then the next thing should be an FF. Wait, what does DEC do? Maybe I'm just wrong about what the DEC does. DEC decrements. I'm obviously aware of that, right? Like that's not the question. The question is, oh, DEC does not set the carry if it underflows. Oh, I thought DEC would set the carry if it underflows. Okay, it doesn't. But it would change the N flag. Which is exactly what happens. Okay, so this is DE6. Okay, so this is DEC C6 that's going on this line. And so C6 is 0, so what ends up on the data line is FF. The next is FF, 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 which is the SBC ALX. So we do FF, so we do SBC, FF, comma X, which, because X is 6, resolves to SBC 5. Oh fuck, I have no idea what's in 5. I think this is where our journey ends. Because I have no idea what's in 5, so I cannot possibly do this analysis further. I mean, the SBC is correct, which you can see because it assembles a 4-byte instruction here. I mean, I guess I can try to RAM watch 5. Ah, it might be 27. 27 decimal. It might be 1B. It is not 1B. Ah, but it modifies A. Ah, right, SPC modifies A. SPC modifies A, so what we end up knowing is that after it ends up being... Ah. Aha. So we don't need to know what's in 05 because we know what ends up being pushed to the data line, which is FE. Good thing, good point, good point, good point, good point, good point. So the next thing that happens is an INC ABX7. well, ANCABX. The 7 is the number of cycles that this address takes and was just includes my table. I should not have said that. INCABX, INCABX, INCABX. So this ends up being FE, FE, FEX. So FE, 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 comma X, which resolves to INC, FE, no, INC, FF04. I have no idea what's an FF04. It's a ROM address, so you could, in theory, check, but it doesn't matter because we know it's 8E. No, it's 8D. It's 8D. It gets read, and then let's just check what 0A, 01 FF04 is, but it should be an 8E. That's a 53. That's a 53. Oh no, wait, it is ALX. No, it is ABX. What is ABX? ABX is FEFEFE, comma 6 is FF04, so we should be at 01 FF04. I think I'm doing this open bus right wrong. I think my bus is driving the wrong way somehow. Okay, so it's a 53. Ah, right, but it is a no. But this should change. Wait, what? I'm extremely confused. If this is an SB, oh, good morning. Good morning. I skipped a line. We run into an 8C. It doesn't matter what we run. We run into an 8C. We don't run into the FE yet. We run into an 8C. The 8C, on the other hand, is an STY. What? This is getting increasingly confusing. I think I'm misinterpreting how something works along this ride on the open bus. But SBC modifies the accumulator, and the last thing that's being modified, that last thing that's on the data line is. Oh no, the last thing on the data line. Oh. SBC doesn't write anywhere, it just reads and then changes the accumulator. So the last thing on the data line is whatever gets read. And so the result of an SBC with carry clear was 8C. And so what we subtracted was how does SBC work again? SBC has this extremely counterintuitive behavior where you need to SEC before if it shouldn't do what it if it should do what it should do. SBC is accumulator minus 1 minus data minus 1 plus carry. The accumulator is 0, so minus data minus 1 plus carry as well. So the data is. So the data was 74. And because the data was the data was 73. The data was 73. And so since the data was 73, the last thing that was read was 73. And so since the last thing that was read was 73, we ADC 73. We ADC relative stack addressing, comma, oh god. We ADC. No. Fuck. Okay, I have no idea what's happening here. I think I give up on this open bus ride because like this is just too much things I don't know. You could. I think the point here is you could, in theory, stack trace this, but the thing that confuses me is no matter what we end up with here, this is some opcode that just repeats itself. And it seems to stop at 210C, and that shouldn't be the case because 210D and 210C are still open bus. I mean, I know there are also hardware registers, but they are hardware registers which are open bus when read. We can just say COP crashes the game, it would be our little secret. But COP doesn't crash the game. Somehow the COP is not the thing that crashes the game here. The thing that, I mean, I guess the thing where you could say the game crashed is this PLP right here. This PLP, out of everything in the game, this PLP is arguably what crashes the game. What's the address that changes behavior on? 210C or 210D? Because you see the next address is the FFFF, so I guess one of this 210C BR. I guess 210C gets. Oh, 2106 change. Oh, you're right. You are correct. Good spot. Good spot, good spot, good spot, good spot, good spot. 2106. Is 2106 readable? No, 2106 is also not readable. Either rex.txt is inaccurate here. But this is odd, right? Because usually whenever rex.txt is inaccurate, the emulator should get it wrong as well. Huh, this is odd. I mean, maybe this is one of these changes, one of these things that was recognized very lately, or maybe I'm just wrong about my analysis of what's happening here. But I'm pretty sure this must be some stable address that just would repeat until some stable loop that would just repeat until you eventually hit something memory mapped again. But none of these are memory mapped for reading, according to, well, something. Rex.txt, anyway. Okay, maybe. So this is extremely weird. This is a very hard case to analyze. By the way, what's going on here? We CMP 2140, we BNE. And what's going on here? What is going on? Something is wrong with this trace log. Something is wrong with this trace log. This trace log cannot possibly be correct, right? What happened? Where did my scan lines go? Hello? Hello? What? What? What is... Where... Hello? Sorry. This is not normal, right? The V counter doesn't just jump from 224 to 236. Something is terribly wrong here. Wait, does it just throw up when it tries to disassemble, when it tries to trace lock more than one frame or something? Is it just unable to trace lock more than one frame or something stupid? Because... Hello? Wait. What should happen here? Right, an NMI. This is where an NMI should set in. Does this just... Also, actually, what the fuck is this? Hello? Why is there a 1 here? Did we enter emulation mode? Ah yeah, XCE. No. Carry was not set. Wait, carry was not set. Carry was not set and we XCE'd. We left emulation mode. Ah, but then we RT. Carry was set on that line? Oh, carry was set on that line. Sorry, oh yeah, I'm always confused about reading trace logs. Yes. Yes. Sorry, I'm always confused when reading trace logs. This is the address and this is the current state of the processor. The resulting state of the processor is on the next line. I'm always confused by this because the state of the processor is printed after the instruction when I feel like it should be printed before the instruction because somehow this is the state of the processor, then we do this instruction, but rather we do this instruction when the processor is in this state. This is how you should read this properly. So we do this instruction. This is the current state of the processor. So the carry is currently set. So we are currently entering emulation mode. So I guess what's happening is that this trace log is unable to correctly trace log an NMI happening in emulation mode. Because you see what happens is that the NMI routine is missing. It's just missing. There just is no NMI here. But the NMI should hit, right? Like the NMI should hit and we should... Oh! Oh! What's the NM? There is a different NMI vector for emulation mode, right? No. Wait, it RTIs immediately. No. It's not the RTI routine that's missing. There's more missing than just the RTI routine. Because the NMI routine is just pointing into an RTI straight up. Okay, I have no idea what's going on. Let me tracelog this with a better emulator. Do I have a better emulator? I have a different version of BizHawk. Surely that's going to be better. Sorry, wait for a second while I try to set up a... Wait, that's the wrong ROM. Stop. Don't load this ROM. I don't need to load this ROM. Oh yeah, of course. I mean, somehow analyzing this crash is important, you know? Sometimes you need to analyze your crashes. Sometimes you need to analyze your crashes, you know? That's what if we end up at 4218? That would be hilarious. Wait, which power-up state am I even analyzing at this point? 76. Okay. Let's just... you'll see the tracelog that I'm currently setting up. It's not interesting at all what I'm doing currently. I am just trying to find out on which frame I collect the power-up. I guess it's this one, so let's generate a tracelog. Log to file. Ran a few frames. Let's see where this is going. Let's read a tracelog. Wait. This is where my tracelog is. Okay, so this is the tracelog here. It's a bit cleaner. Okay, so which address did I want to look at? Again. 8A03. Let's see. Wait, what? Oh, this is fast ROM. So we go to 81, 8A03. Okay, so this is where we start, and then we COP, and then we RL, and then we... go here. And then after all this magic, yeah, okay, great. So note, also this version of BizHawk cannot disassemble what happens in open bus, but at least it emulates the open bus the same way, so we end up at the same thing. So let's check what happens. But at least here. At least this still works. So do we ever get free out of this? Because this seems like an extremely infinite loop to me. Yeah, this is what's happening. Forever. And ever. We never free ourselves out of this loop. The only thing that confuses me is... why is there no RTI? Yeah, I mean, it's CMP 2140, but 2140, I feel like that's open bus, right? No, that's readable. Wait, what is this? Oh, it's waiting for the SPC to respond. Ah. It's waiting for the SPC to respond, but the SPC is just playing back a song. So it's doing nothing. Okay, here's something hilarious that you could make with this. So you know... Anyway, yeah, I don't think interrupts are disabled in emulation mode. It might be that that some of the garbage code before has disabled the NMIs, because I mean you can do that, right? It might be that at some point in this entire odyssey the NMIs got killed. That would be an extreme coincidence if that happened. I mean, I guess we can check. Then I'll make my other point, which is a bit of a funny point. Okay, so where would you disable NMI? Wait, where do you disable NMI again? Wait, there's an easy way to check this. $4,200. Enable NMI. Okay, so 4,200. Let's just check if 4,200 ever gets... Okay, that's not it. Okay, I have no idea. I feel like there should be an RTI happening once in a while. Apparently it doesn't. Very confusing to me. Anyway, so here's the other point that I want to make is, So you know how in ports you can write to the SPC out register. You could actually make a port that breaks this loop after an indefinite amount of time. Like you could actually, you could actually make a port, let it run on the SPC, and then force the player to like listen to one entire loop of the song. And only then does it break this loop. And before Magikey was like completely trolling, and that's what actually happens here. If you listen to one complete loop of the song, you you get freed. Time to disassemble the song. That would be so hilarious, though. I have the feeling like I'm just going to pretend that this always crashes. Because like it ultimately runs into a PLP, and if it runs into a PLP, then... Why do you think I picked a really long song for a single screen? Yeah, okay, so anyway, this freezes forever, so... Yeah, I really wonder what's going on. Wait, no. Wait, Datsun's video is... Datsun's video is the dumb break that I don't know about, right? It's only Magikey's video that's like 35 minutes. I think Datsun's video is like 5 minutes, right? Oh no, I also didn't watch any videos of it. I just saw the video length. And the point is, Datsun now uploaded like a much shorter video. Datsun did Ace with the wing block. Okay, yeah. I mean, that makes a lot of sense. That explains why he said, yeah, it's so stupid, he's not even sure why he would reject over it. And Datsun broke this puzzle, by the way, expected. Of course he does. I mean, I'm not telling you what I did today, but it might have ramifications for my future hacks as well. It is though the most stupid thing I've ever done. Like if I do end up requiring this in the hack, this is like stupid. I have a feeling like there's going to be a bunch of very weird pit hacks at some point. But okay, anyway, so what I'm doing here seems to be running into a dead end. So I mean, I guess... So I mean, okay, to summarize what happened in the last 3 hours. right? Because somehow, if at some point in the last 3 hours you didn't pay attention, you might not realize what actually has been going on in all of this, to all of this disassembly reading. So the point is, I investigated the following question. How do you get a winged block in your... how do you get a winged key into your item box from collecting a mushroom? Observation 1, there are 5 power-up values that work. Observation 2, out of these 5 power-up values that work, they all jump to some indefinite point in the code. And I found out these 5 values. And one of them... Okay, so the one of them is the thing that the thing we are currently looking at the tracelog of, which, to be blunt, just crashes the game and that's it. Stop thinking about it. I mean, I know I've been talking about this crash for like over an hour at this point, but it's just a crash. Like, there's actually nothing to be said there. The second is ends up just teleporting you so far under the level that you automatically die and you can do nothing about it. You will always end up at Y position roughly 32,000. The third one jumps somewhere straight into the springboard code, bouncing you up into the death blocks below, above. Great. The last one, the fourth one runs pretty quickly into a PLY, but without the matching PH whatever. This misaligns the second crashes. Leading to the fifth possible power-up. Power-up Hex 37. Whose power-up transformation routine jumps to 15E9. Now 15E9 is part of the RAM. And so you might be inclined to just manipulate whatever's on 15E9. But 15E9 is the sprite index for the current sprite that is being processed. So the first thing that is being run is an ASL. In fact, it is an ASL DP. So we run 15E9, 15EA, and so the next thing being run is 15EB. I guess one thing I should check is what is actually currently in 15EB. It's 0. And now it's in level, it's 68. What? That is actually extremely interesting. I think I should look at what's going on here. So we execute 44 MVP. Okay, maybe I don't want to maybe I don't want to analyze a code that starts with an MVP. Help. I don't want to analyze code that starts with an MVP. Okay, time to run a tracelog again. I'll just tracelog it again. Hi, Bugs88. Welcome to... I don't play the game anymore and just read tracelogs. I've been doing this for like approximately 3 hours at this point. The next thing I will be doing is I will be analyzing a tracelog that starts executing code in RAM. Please don't ask why. I cannot explain anymore. Why not? Okay, let's you'll quickly get the next trace log to look at. Please wait while I'm setting up the next trace log. Do we even have a sane way to set any arbitrary power-up state yet? No, but if I don't have any reason to do that, then I'm not even going to look into it. But somehow the moment you have a brown platform, you can in theory do it, I think. Maybe, possibly, perhaps, maybe. Not sure. But somehow there are ways to like jump around. Between power-up states. They're not like ultra stupid. Okay, they are ultra stupid. I'm going to admit it. They are ultra stupid. Okay, let's trace log. Okay, so here's our new trace log. I'm not a fan of this trace log. It has a lot of MVP in here. This was the point. Why I said, yeah, maybe I don't want to analyze this. You wonder if any hacks apply the wait replace patch to get more usable trace logs? What? Okay, so we start at 15E9, we ASL 30, who cares? We do the MVP. But why would you want to do that and why would you care, like, at all? And how does it improve the trace log, like, except for, like, extremely marginally? Also, what the fuck is going on? Bank 6C and Bank 58 are completely open bus anyway, right? I mean, we're writing to ROM. We're copying ROM from ROM to ROM at this point. Or I think we might be copying open bus to ROM? Or ROM to open bus, it doesn't really matter. I think this command is doing nothing. I didn't run the tracelog enough. Typically, like, I will admit, typically, like, this many frames is enough to get a usable tracelog, but not if there's a single MVP instruction that takes several frames to run. So let's check what happens if after the MVP is done. Okay. Please don't tell me I need more tracelog more than that. This is just stupid. What are we even doing at this point? Wait a second. If we do an MVP with a equals 0, we're overwriting the entire RAM as well, right? '60 and 58, I think those two have RAM mirrors. Wait a second. How long has this been going? So you're telling me these banks don't even have RAM mirrors? So they're completely open bus? Then there's like nothing memory mapped in here, right? Oh, wait. Uh, I mean, definitely the writes are going to open bus, right? I mean, maybe, I'm not sure if you could call a ROM write open bus, but I don't even care. It's a ROM write. Like, ignore where the, but actually, is the, are the hardware registers mirrored? Are the hardware registers mirrored? Because it might be that accidentally some of these, because they don't read and write from the same address, right? Like they, somehow this might overwrite some of the hardware registers, I feel like. Can it? It should be able to, right? Because I mean, the MVP command is just writing, so it should be able to write to hardware register. How long is this going though? What? Okay, this looks like open bus to me then. There are no hardware registers. But no, wait. I'm confused. The stack pointer is moving through all of this. When does the stack pointer move? At what point does the stack pointer move? When does it move? Why does it move? Oh god, oh god, oh god, oh god. Yeah, of course, this happens. Yeah, of course. Wait, no. Wait, why does it happen? Wait, why does this happen? Wait, why does this happen? I don't understand why this happens. Why is there 15 EB in 00? MVP ends BRA 1584, BRK00, BRL 15EB, but why is there 15 EB in 00? I'm confused. It's 15e9 plus 2. Oh. It's 15e9 plus 2 because it's a relative branch. Thank you. 15e9 is in 0, 0. And this I understand. I understand why 15e9 is in 0, 0. That makes sense. This is how we got here. This is how the pointer trampoline works. I mean this is how the pointer how execute pointer works, right? To say it with normal words. This is how execute pointer works. It writes the target address to 0 and jumps there. But this means that if you wait long enough, the stack overflows and overwrites everything. And what happens then? Because the stack pointer moves, right? So at some point it overwrites the... Yeah, okay, I just crashed the game completely now. Right, because what happens here is that the stack pointer moves every time this happens. Every time the MVP happens, is done, the stack pointer moves. Because there is a BRK, which BRLs back into the MVP. And the BRK pushes 4 bytes to the stack. So at some point, the stack pointer moves and overwrites what we wrote to 0, 0, and at that point, the BRL goes somewhere else. But of course, at that point, you have corrupted the entire direct page with the same repeating byte pattern, or almost the same repeating byte pattern. No, the same repeating byte pattern. And I think at that point, the game is like too far gone to be rescued. But technically, it's possible, you know? I mean, some of the stack pointer moves, right? I mean, some of it just happens, right? Like, you just wait long enough and the game crashes completely. Because every time this MVP is done moving 65,536 bytes from nowhere to nowhere, so from open bus to open bus. After this MVP is done doing that, it moves the stack pointer by 4 bytes. So after it has done that 128 times, so after it has moved... how much? How much has it moved then? Let's say like 7 megabytes worth of data. Like after this processor has moved like 7 megabytes worth of data from OpenBus to OpenBus, it is done completely corrupting the direct page using nothing but BRK stack pushes. And then we can finally be done. I want to point out moving the stack pointer takes long enough that it happens exactly 3 times during this trace log. No, maybe 4 times. No, 3 times. But yeah, after the trace log would take 7 million lines if you wrote it out, right? Because each line moves 1 byte. This is so stupid. This is so stupid. By the way, the other thing that confuses me is that what happened to all of the NMIs? Is NMI just disabled at that point in the game? It shouldn't be, right? Yeah, I guess it must be that one frame, but like, wow. Hmm. Okay, with that said, so this is the MVP crash. Okay, so I have analyzed 5 power-up statuses. We have now successfully accomplished nothing. Like, actually nothing. I mean, somehow this analysis has led to nothing. I've analyzed power-up jumps for over 3 hours. And none of them do what I want them to do. You did the same analysis and you came to the same conclusion. There's one thing I haven't noticed yet. Do you mean by that that there is something in my analysis which was like just incorrect, or somehow that my analysis just incomplete? Because somehow I do see a way to push this analysis slightly further, right? Like I do see ways to do that. For example, here's one thing that I haven't done in my analysis. Who says we actually need a key? Technically incorrect. Wait, can you say which power-up state I analyzed incorrectly? Because somehow now I would move on to like say, okay, we don't actually need a key, we need to wait to end the level, which is not the same. Wait, 76 I trace locked. I feel like my analysis of that case is complete. Are you telling me my analysis of case 8D is wrong because I said PLY would immediately crash? Check what 76 puts in your item box. Wait, are you telling me the starting analysis was wrong? Wait. Am I just that dense? Um, oh, I see what you're pointing out. Why the fuck would you edit this? Why the fuck would you edit? Why would you enable fast draw on on a glitched puzzle hack? I just realized that like the fact that fast ROM is enabled means that so much garbage is going to be edited. To be fair, I think actually Koeda 2 also has fast ROM enabled. But sort of it doesn't rely on anything that weird. Okay, let's look for 0Ds again. Wait, but this code is completely changed. Why is so much code here changed? I'm a bit confused. Why is so much code here changed? Like, this D right here, this 0D right here is different. What? If you look at the hijack, it might spoil part of the puzzle. How can a puzzle be spoiled by disassembling the ROM? I refuse to accept that a puzzle can be spoiled by... No, this is that's the point. That's the point. That's why I said this is never edited, because this is never edited. Like somehow some of the reason why this is the way it is very weird. Like this shouldn't happen. This is unnatural. Wait, what? Hello, can I please? SEC, SBC, ASL, ASL, RA, TAY, LDA C510Y. This is correct. BEQ JML 90B01F NOP. Okay, I guess we're going to 90B01F. And it's a JML even. It's a JML. It's not even a JSL. We're never going back. Okay. 10B01F. 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 B01F. STZ. STA 02 D2 CMP 14. What the actual fuck is going on here? LDA A3 CMP5F. So it checks for the sprite number of the sprite in slot 5. And if it is 5F, STA 0DC2 CMP14 BEQ. LDA 0B STA 1DFC JML. Okay. C54D. Where do we merge back? C54D. Yeah, no. This is not LM code at all. Also, I think LM typically doesn't hijack with JML. It hijacks with JSL as you should. As you should. Yes, it's faster. JSL is just faster, right? I'm not crazy, isn't it? Is it not? Maybe it's not faster. Maybe it's slower actually. Wait, is it slower? It's slower probably. Wait. Is this maybe genius? RTL is 6 cycles. How long is JML? Maybe this is genius. Maybe it saves 1 cycle. It saves 2 cycles. It saves 2 cycles. Ah, so this is actually genius. This is actually much better. Fuck ROM space. -2 cycles. Yes, 2 cycles saved. By the way, it's not +3 bytes. Oh wait, actually no, there's even a deeper reason why we don't RTL, because we don't JML back to the same place. No, it's not just +3 bytes because it's used multiple times, right? So it's actually at least plus 6 bytes in these cases. But it's plus 3 bytes for every RTL being converted into a JML. But okay, so what do we do here? We check whether the sprite in slot 5 is a brown platform on a chain. A brown rotating platform. So we check. Okay, so we check. What is 14? What is this 14 doing? LDA item box sprite Y. EQ. Gain bytes and lose cycles by BRAing to a previous GML. Yeah, but I mean, save the cycles. Don't care about the bytes. Save the cycles. I have, over time, I have become increasingly convinced that saving bytes is useless and you should save cycles instead. Because nobody cares if the ROM is 4 megabytes. How'd you get -2 cycles? It's -6. What? Oh, because JSL is also so much. Wait, JSL is so much slow. Did I misread how slow JSL is? Ah, yeah, JSL is 8 bytes. Yeah, 8 cycles. You're right. Yep, you're right. You're right. It's saving 6 cycles. Beautiful. Okay. Okay. What is this 14 doing? Wait. This 14 is checking whether you get a winged cage into your item box, right? Because it goes STA0DC2, CMP14. So it checks whether 14 was written to the item box. But 14 in the item box... Ah, no, 14 in the item box is not the wing cage. No, wait. Off by 1 error. Oops. It's checking whether you get a cloud in the item box. Ah, it's cloud, not cage. It's cloud. Wait, but the ways to get cloud in the item box... What the actual fuck? This checks whether you get a cloud in the item box. Then it checks whether there is a brown platform in slot 5. No, whether there is no brown platform in slot 5. LDAA3 CMP5F BEQ LDA0B STA1FC JML01 C560. What's C560? Okay. Okay, unless I mean, somehow my brain is probably becoming like fried from reading too much assembly over the last 3.5 hours. But it seems to me that what's happening here is that we check whether we get a cloud in the item box. If we get a cloud in the item box, we check then whether there's a brown platform in slot 5. And if there is, then we do this, and if there isn't, then we skip the give power up routine and instead just do the grow up and get mushroom routine. In other words, Cloud does not jump to open bus in this. And instead, if you would get a Cloud, but there is a brown platform in slot 5, you instead get an AE into your item box, whatever that means. What's 73 plus AE? Ends in 1. It's the same as 81 plus A0. It's the same as 81 plus A0, which is the same as 21. So you get a 21 into your item box. What's sprite 21? It's a moving coin. What the fuck kind of troll is that? Wait, is it a moving coin? Maybe it's not a moving coin. Wait, I have to check if this is a moving coin because I don't actually know how... No. No. It must be a moving coin. Must be a moving coin. No, should be a moving coin. And then it plays the sound and then it JMLs back to the actual routine though. Then it still pushes you to open buzz. Usually, I guess. What? So if you get a cloud in your item box, then the get power up routine is skipped. Except if there is a brown swinging platform in slot 5, in which case the cloud is replaced by a coin and the get power up routine is played regardless. This is certainly one of the hijacks of all time. 7 out of 10. Okay, so this is ruining my ways to get a key. I see. If you squint really hard, you think you can see Mario. Yeah. Mario must be hidden somewhere in this castle. At this point, this is just... Okay, so, I mean, at this point, I don't know what the stream is even about anymore. Maybe at some point it was about Mario, but at this point it is just about... I don't know what it even is. Right, I mean, you still see the Berge, right? And the Berge, they just tell you that this is still Mario. In case you have forgotten which game we're playing here. Or we were playing before the disassembly reading started. But okay, so... Yeah. That's great, isn't it? So here's the thing I want to point out, and here's a point in my analysis that I haven't made yet. Which is, nobody said we need to get a key, right? No, a keyhole doesn't work. But you know what would work? Maybe it wouldn't work actually. No, I think an orb would work. You see, if you look at this, then where's the middle of the level? Okay, the middle of the level is like here. Maybe it wouldn't work. Maybe the level is just constructed in a way such that you can't orb it. Because the orb would drop down here. This is mean. Where would the orb drop down? The orb would drop down here. So you could collect it while like here. Ah. Seems to be just in a position where an orb would be not working. Ah. I guess that's something I can check in an emulator. By the way, there's still this message box, right? I have not forgotten about this message box. I just still don't know what it means. I still don't know what any of this means. Anyway, I wanted to check if my... This is not looking good for orb, I agree. But I want to just double check. How do you get an orb in your item box? No, you could orb. You could orb this. So if you get an orb, then you're happy, right? So this is definite proof that you can orb this. If you get a... Does it trigger the correct event? Yeah, orbs activate the secret exit. But also there is no right event. I don't even know what the correct event is. To me, beating the game involves getting 3 exits. I have no idea what other goal this hack has. Like, the game never told me how the events look. The only thing I know about this hack is that it has 3 exits, so as long as I get 3 exits, I'm good. And I mean, if this is the event, then looks to me like I have 3 exits, right? Like, I need to know what winning the game looks like, but to me winning the game looks like 3 exits. Anyway. Okay, but then the question becomes, how do you get an orb in your item box? So it's D7. The question is... I feel like okay, let's look for D7s. Do I see a D7? 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 There's a conspicuous lack of D7s over here. Ah, there's a D7. And I don't see any other D7. So there's a D7 here. It would call routine E6. But I think we all know that routine E6 doesn't crash. Although I guess it's time to check what that routine actually is, because I don't actually know. I guess I must have seen it at some point. Because I have looked into stuff like this at some point, but... And this is one of the ones that you actually get from Chuck Eats, so somehow makes it more likely that I've run into it at some point. So let's look at where the pointer at 720 is. 95C6. So let's see what's at 95C6. No idea what this is, but it is something. Ah, it's just some sprite code. Ah, that's fine. By the way, I love this code here. PHP ROR PLP ROR. What does this do? It preserves the carry. Amazing. Amazing code. Love it. This is code. This code is art. Anyway, just a side note. Um. Okay, so yeah, so if you reach power up state 87, then you also win. I guess that's the other thing to note. What happens if you get a cloud in here? Right? What happens if you get a cloud in here? I mean, after all, the cloud would not crash as it would normally do, right? Because normally getting the cloud would open bus in here. But as we just read, maybe I should get rid of this orb. How do I get rid of this orb? I guess that's how you get rid of the orb. Okay, so somehow being in a cloud does not prevent you, does not allow you to go above the screen, the camera. It seems. Okay, so getting a cloud does not allow you to go above the level. That's a bit unfortunate. I had hoped it would. But it's rather that the... Yeah, okay. Yeah. That's just the thing of how the cloud works. With the cloud pushes its momentum onto Mario, but Mario pushes his position onto the cloud. So if the camera pushes Mario down, the cloud gets pushed along down with him, right? It's not that. It's not that the cloud allows Mario to go above the level. Unfortunate. Unfortunate. Yeah, okay. Maybe it's time to find out what this message box says again. It's a very confusing message box. Zero 05 could refer to slot 5, and that's about all the IDs you have. Yeah. Yeah, I mean 05 I guess refers to slot 5, but what else? Minus 16 could refer to horizontal speed, to a vertical speed. It could refer to sprite F0. Horizontal position, vertical position. 1A could refer to a lot of things. Hashtag one line Yoshi paw. H70B10, 94. Is 94 a number I know? Is 94 a number I've seen before? Is 70 a number I know? Is 10 a number I know? Is 91 a number I know? Is 94 a number I know? You in primary school? Yeah, I mean, sometimes you should just ask yourself, is this a number I know? Not just is this a number I've seen before, but is this a number I know? You know this number. Sure, I mean, I've seen 94 before in other contexts, but do I know the number? Do I feel the 94? I think today I don't feel the 94. Let's just double check whether AE is really a moving coin, but I think AE is a moving coin. It's not so moving. It's a coin. That is moving. Yeah, I mean, I guess it is moving. Just in a different direction than usual. I've never seen a moving coin move like that before, you know? But is it permanent and can it wrap? That is important. It is permanent, yes. I have no idea why this is important. But we can now loop a moving coin. I think what I should check, even though I have no idea why I would check this, is can you somehow get a coin? Can you somehow get a cloud from collecting a mushroom? Like ever? Yes, with power up status 59. And with power up status 74. And AC. And E0. There's a lot of clouds you could get. And they don't crash. Very interesting. This is extremely interesting code. Especially the part where it takes a cloud in your item box and silently replaces it with a moving coin. But only if there is a brown rotating platform in slot 5. Like, what the actual fuck? Yeah, okay. I'm just confused about everything. I might just stop for the week. Like, this week was the stream of... I try to get useful stuff in the item box by collecting a mushroom. And check whether it crashes. In doing so, I stumble across a random hijack that somehow replaces clouds in your item box with moving coins, but only if there's a rotating brown platform in slot 5, and otherwise it just skips the get power up routine of getting a cloud. In other words, it prevents you from reaching open bus in that way. Which is either a bonus or it's a I mean, either that's good for the player or that's bad for the player, depending on how much the player likes open bus. And I don't like open bus, so I guess it's good for me. Except that I don't know why I would want to get a cloud in the item box. I mean, I guess you could use the cloud in the item box to maybe push down the brown platform? Maybe that's somehow possible, but... yeah. Anyway, I think that's it for this week. I think I'm done with disassembling this game for now. I've played approximately 0 minutes today. That's not entirely true. I've played like... at least the game... I've at least played the game for like 5 minutes today. Maybe even 6. You see? Gameplay. Wow, gameplay. Wow, gameplay. Wow, I can jump and run in this jump and run. Yeah. Wait, actually that's an interesting point. I don't remember seeing a save prompt. Despite the save prompt option being checked on the overworld. What's going on there? Wait, what? Wait, on the overworld the save prompt option is checked. On the 3rd level. And on the 3rd level only, but I don't actually remember seeing a save prompt after this level. Wait, I guess I need to double check that for a second. Am I just misremembering? Or was there just no save prompt? Ah, right, you need to move to another level. Okay. Right, you need to move to another level. I mean, what would happen if I actually saved the game right now? If I now reset the game, I would have 3 exits, right? Yeah, okay. Oh no, now I'm stuck here and I don't have any exits. By the way, I find it very interesting that you replaced most levels on the overworld with castles, but not Donut Plains 1 and not Butter Bridge 2. What's going on? What is that supposed to tell me? Like, everything is a fortress or a castle, except for Donut Plains 1 and Butter Bridge 2. Is that a subtle hint? We may never figure out. This is Donut Plains 1. You look at the level. You notice it just looks like it normally does. There's, I think, nothing wrong with this level. You look at... Wait, is this Butter Bridge 2? I don't even know which level Butter Bridge 2 is. Is this Butter Bridge 2? One of these two is Butter Bridge 2. I think this one is Butter Bridge 2 and the other one is Butter Bridge 1, right? Oh, anyway, it doesn't matter. In any case, have a good night. Thanks for watching. I'll see you next week with more of this, I guess? Yeah. Have a good night.